all of our existing assumptions on how software actually gets built are being rewritten. Right now, teams are shipping in hours what used to take weeks. Designers are prototyping in code, developers are increasingly managing teams of agents, not writing functions or tests. This is the new default. Well, it's actually a video series by Montreal exploring the AI revolution, reshaping software development from the first idea all the way through to production. In each conversation, we go deep with the people building at that edge, the practitioners and the skeptics and the creatives, to figure out what actually works and, most importantly, what's coming next.
Tell me a little bit about your recent history, because I think your current thing is brand new, so it's emerging, but the project you worked on previously is a thing that you're probably a bit better known for over at LangChain and LangGraph.
Yeah. More than 3 years ago, maybe almost 4 years ago now, I joined LangChain as the first employee. And so I was there for around 3 years, ended up moving to San Francisco and while there worked on a bunch of different things, led the open source team, created LangGraph, and was just pretty much in the center of what was happening with LLMs.
Yeah, that must have been in San Francisco over the past 3 years working on AI. I always understood it was like LangChain, language chain, the kind of spine for autonomous agents and workflows. Is that correct? Tell me what in a sentence LangChain was, what you're working on over there.
Yes, LangChain was the first open source library that put together all the key like patterns and what became known as like cognitive architectures of how people use LLMs to create agents, how they organize them together with other code like tools and orchestration. And then, after that, it evolved into Langsmith, which was the first and biggest AI observability platform. And then LangGraph, which was what I created. And that was the first framework for durable execution for agents, which is really actually all about getting agents to setting things up so that agents can work autonomously for as long as possible. Because the longer that an agent runs for, the longer that any code runs for, the more mistakes and issues are going to crop up. And that's where the requirement for being able to snapshot the work as it's going and being able to retry, but not from the beginning, and being able to see progress as things are happening. So like streaming and being able to interrupt the work for human in the loop workflows. And that was kind of the motivation for all of that.
So the project and the work that you're doing at the moment is very connected to that. I think it's fair to say it's an evolution of that type of work. So the more you understand that to a degree, the more what you're working on now makes sense. Because you were doing that 3 years ago. I think in the past 12 months, obviously OpenClaw, I don't know what it's being called now, right? It's like AI OpenClaw or something like that. That's the famous variant of a lot of these ideas that you're talking about. But LangChain was pretty well known. Give me some stats, just to give me a sense of the scale of that work, and it went into OpenClaw.
Yeah, obviously, LangChain is still one of the biggest open source libraries out there. I think I don't know the stats off the top of my head anymore, but there's like more than 100,000 GitHub stars. There's many millions of downloads per month across all the libraries. LangGraph itself has, I think, over 20,000 GitHub stars, also millions of downloads. So,
what were your thoughts when everything blew up around OpenClaw? Right? Because is that not the kind of successful implementation of a lot of the ideas that you're working on?
Yeah, I think in some ways, you can think of them as different layers. LangGraph and other LangChain tools are kind of the infrastructure that enables these models to be used in autonomous agents as they get better. And I think OpenClaw showed up when it showed up because we hit an inflection point in the capability of the models. And so these ideas that we were playing around with for quite a while before were finally becoming more mainstream as more and more people realize that you can actually make very long running agents with models.
As somebody who was like first engineering employee in the business, I'm only talking about this because I think it's just like contextually so relevant. And then I think you wrote the book on LangChain, right? So there's like a public, like technically there's a published book on it, right? That was you.
Yeah.
You did LangGraph, right? So it's like you were right at the center of that. And then how did you feel when another product came along and it had been stood up by a single developer and got all of this attention? And I think it was probably using a lot of the ideas and the work that you had put in place previously, right?
I think LLMs are a tide that lifts all boats, right? We're working at different layers of the stack. LangGraph, LangChain, even what I'm doing now is more like infrastructure that enables all the people that are building agents, whereas OpenClaw is just one implementation of that, obviously a very popular one. But so I think overall it's great that LLMs are around and that more and more people get familiar with these ideas.
Oh, I know. I love it. I absolutely love it. And I was speaking to somebody yesterday who was actually doing some financial modeling, and he was it was right to your point. He was just saying, the longer you run it, the more small mistakes it makes. But if you run for a bunch of time, it compounds and you're 20% off, and just really struggling with that problem. And I think that's something that you're working over at your kind of new company. So tell me a little bit about that, what you're doing at Witan, the problems that you're trying to solve, because I think it's in that direction, right? At least initially it is.
Yeah, the overall idea is that one of the things that I've seen over the past 3 years is, especially for non-technical users, like the people that are not reading the news about new OpenAI models every day and stuff like that, the step changes that they notice in AI capabilities are actually very often about new tools rather than new models, because they actually enabled the overall system, the agent, to ChatGPT for most people to do something new, like when web search was added or when the ability to run code in a sandbox was added. That was a big step change for people. And that was the motivation for now focusing my time and on building the tools that we think are missing in order to make these more autonomous, long-running agents possible. And the reason I think something is missing is, as you want agents to run for longer, obviously that requires model capabilities and the labs to keep making the models better. But it also requires that the agents can verify their own work as they make progress. Because otherwise, if you leave an agent running overnight, if it tries to do 12 hours of work without validating things along the way, it's just gonna, as you said, keep compounding errors, right? So having tools that have those verifiers, that validation loop built in, that's key to making this possible, really. And the other thing I think is agents are only as useful as they produce outputs and artifacts that are useful to the human users on the other side. And very often in knowledge work, that's producing things in a file format that people are used to using in their work. So an Excel file or a PowerPoint file or a Word document, stuff like that. So that's what we're building. We're starting with a headless Excel and headless PowerPoint that touch on all those parts.
Okay, give me a sense of Witan Labs. So the company is called Witan Labs, that like building these things inside. You're, I think, 7 employees, mainly UK based. You've done
we have one person in New York and one in Lisbon, but the rest is in London.
And you've been going for about 6 months?
Since November, yeah.
Okay. And you've got a small round that you've done, and you're building those initial pieces at the moment.
Yeah, exactly. We raised a little bit of money at the beginning, and now we're just focused on building out these initial set of tools, and we're getting the word out there about autonomous agents, really. Because I think in some respects, we're a little bit ahead of what people are building today. I think a lot of people are still focused on building these like co-pilot agents where there's constant human attention. So we're building for the future. So yeah, a lot of what we do is also making sure people understand the power of autonomous agents.
So is that a technical differentiation, like autonomous agents versus a co-pilot tool? So how do you see those two things? Give me your distinction.
Yeah, if you ask different people in the industry, I'm sure you'll get different answers. If you just think of a continuum of the running time of an agent. So it can be all the way, or of an LLM powered thing, can be all the way from 5 seconds if all you're doing is ask a question, get something back, or all the way to, I don't know, 5 hours or 10 hours, right? And my distinction between a code, and what I mean by runtime is how long does it run until it asks the human user for some input again.
Okay.
And my distinction between a co-pilot and a autonomous agent really is just, I think there's some point in that line where it takes a long enough time to ask the user again for some input that the user is going to go and do something else. And so that's where I would start calling it an autonomous agent. And anything below that, I would maybe call a co-pilot.
And why is this a difficult thing? Because it feels to me that actually it's something that you should be able to do. You can build a little loop. You can just say monitor this and return that and then monitor it. Why is it a difficult problem to solve? Is it guardrails? Is it governance? Is it token use?
So technically making an agent run for 12 hours is not hard. What's hard is making it run for 12 hours and producing something useful at the end. Because all that stuff like around making sure that it can actually run for 12 hours and I don't know, if something goes wrong, you retry. That's a lot of the stuff that LangGraph also solved. But then the next level up is ideally you want that agent that's running for 12 hours and consuming a bunch of tokens to actually produce something at the end that you're going to make some use out of. And that's where it's really important to make sure that the agent has the ability to verify its own work and that it produces work in a format that the user can then review.
You were talking a little bit about a new kind of mental model or framework called Oracle-driven development.
Yeah. So that is at the same time as we're building stuff for agents, we're also using agents in our building process, right? We've done a lot of experimentation of what's the best way of using coding agents, especially in the domain that we're working on. And I think one of the things that has come out of that is what I think I'd characterize as like an evolution of test-driven development. Test-driven development is just the idea that, and it's super useful for agents in general as well, is the idea that you write the tests before you write the implementation so that you start from, okay, here's my 15 tests and they're all red because I haven't written any code. And now as I write the code and I fix the bugs, eventually they start to turn green until they're all green and then that's done. But with test-driven development, there's still one part that's missing, which is what tests do you actually, like what is the behavior that you're looking to enforce and make sure is correct? And that's where the idea of Oracle-driven development, which is just one possible name for this, comes in, which is actually using an agent to also define what those test cases should be. And I think in order to do that, there's two ways to do it. One, you can take a shortcut, and if you find a really good open source library that already has, a really extensive test suite for the problem you're solving, even if it's like in a different language, because coding agents are able to code in any language, then that's a good way to get started. Just borrow their test suite, and then basically the job of implementing that behavior is super simple because now the agent just has something to optimize against. Obviously, in many domains, those test suites aren't available. So that's where the idea of querying an oracle of some kind comes in, which is just in some domains, if you're building software, for instance, in our case, we're essentially recreating Microsoft Excel for agents. So where all the behaviors that Microsoft Excel has accumulated over decades, we're re-implementing them in a new code base that can very easily be run by agents in a sandbox, in a server, etc. So our Oracle is Microsoft Excel. Like the behavior that we want our software to implement is whatever Microsoft Excel does with that input. That's what we want to do. That means we actually now take one more human step out of the implementation loop, which is I don't need to define the test cases. All I need to say is tell the agent, please go and implement this feature. And in order to figure out what it should do, just go and ask Excel. So like programmatically control Excel on my machine to figure it out. And that's basically the idea with Oracle-driven development. And there's still a role, like a really important role for the human developer, for me, for my developers on my team to play, which is to define, to like design that loop around the coding. Like, what should the agent, how should the agent query the oracle? What is the oracle? How do you compare? How do you actually extract the right behavior from Excel in this case? So there's still a very creative role for the developer, even in this.
It sounds like a layer above something like goals, which you would give it an end goal. I want you end up here. I don't care how you get there. But this sounds like a kind of a bigger view of that. This is actually, you can have lots of little goals under, but it's a very interesting idea of how to organize the product building. Tell me, what's your setup? Like, how are you guys using it? How do you share those oracles or those goals between different people, maybe in different offices?
It's a good question. We all use like different coding agents. Like on purpose, I've let everyone on the team use whatever coding agent they want to use. If they want to use multiple, they're very welcome to do that. I myself go back and forth between Codex and Claude Code, and I know other people on the team use whatever the GitHub one is called, and Cursor. I think some of them use that as well. And so then how we share things in the end, there's two ways we share things. One is through Slack. Often we'll send back and forth between us on Slack, like a plan file that one of our agents has produced. So basically, it's like in addition to the code review of the pull request at the end, now there's this review of the plan before the implementation actually gets started. And that actually many times produces useful changes, which obviously is a lot easier to make those changes before you start than after. And then it's inside the repo. One idea that we're playing around with more recently is, so skills is a popular thing, right? Lots of people use skills. So we've repurposed the concept of skills, and basically we now have in our repository a skill that is meant to be edited by the coding agents as they're working. So it's a skill that starts out completely empty. We call it a editable handbook, and the idea is as the agent, and we created one for the name of the file format, the behind Excel and PowerPoint is called, so it's called the OOXML handbook. And this started out empty, and then we just put in little instructions that say, hey, every time you like query the Oracle, so Excel or PowerPoint, about what it should do, how the file looks like, what happens when you do this, just make a little note of it. And then the agents just do that as they're working on the task. And we don't even notice. I only notice when this happens, when then I go and open a pull request, and part of the diff in that pull request is a bunch of changes to that handbook. And I never read them because it's not for me, right? It's just for the agents, my agents, my team's agents to read that stuff when they're working on the next task. Yeah. Honestly, I can't even tell you whether this is net positive or net negative. It seems to work, but if you ask me 2 months from now, I'm sure we'll be doing something different.
Yeah, no, you said it's not about coding. It's about creating the environment where that code gets written. And that's what you and your team spend most of your time on, which is you beginning to talk in it makes a lot of sense to me, right? You're beginning to talk like the plan document is where we focus, the rules and the making sure that it's dynamically improving as it goes along, rather than waiting for a moment in time where we give it a big update. It's improving that and making that efficient is what you're focused on. As a small team, you can probably do that. When you get to a bigger team, it probably becomes quite a lot harder to.
Yeah, I think that's going to be an interesting challenge. I think there's probably ways to work around that. For instance, we have all of our code in a monorepo, and that works really well because we're a small team working on a bunch of different parts of the system, and the agents are also working on a bunch of different parts of the system, so it works well. But if we have, as we grow and we have a larger team, maybe it might actually work better both for the agents and for the human developers to have that be more split, so that maybe there's specific skills and handbooks inside each of the sub-projects. And then you always launch an agent, not from the root, but from the specific sub-project. And then you have each sub-team of the human developers work dedicated to each of the sub-projects. But honestly, I'll figure that out when I get there.
Do you feel a bit constrained by GitHub? Just curious, Now that we're having to not only share the code, which it was perfect for, but now we're having to share these big contextual documents. Maybe not so much in your case, but in some cases, those contextual documents, they might be larger files. I don't know if they might be images or image files or high-res files or video files, things that Git doesn't necessarily handle so well because context is becoming in. Do you know what I mean?
Yeah. No, it makes a lot of sense. Partly where I think GitHub is working well for us, but on some parts of the workflow, we're actually skipping GitHub. So for instance, when we share these plan files among the team, that happens in Slack, not in GitHub.
Right.
Because there's no, even though maybe it could happen in GitHub, maybe as a GitHub issue, or I don't know, but it's just more natural to just send it in a Slack thread. And I think maybe that's a sign of things to come as more of the software engineering workflow becomes about handling non-code files, then maybe more of that stuff starts to happen outside of GitHub. I do think this, probably lots of people say this, but as agents produce more and more code, I don't know that the GitHub PR review UI is necessarily the best possible experience to review this code. Yes, I many times end up having a much better time reviewing it locally in my code editor, which honestly I only use for reviewing code now. So yeah, I'm sure there's things to do there as well.
Yeah, I use it. I live in VS Code for reviewing context documents and seeing what the agent sees. So it's a totally different use case for what it was built for.
Yeah, exactly. My setup is I have half my screen is the terminal or the codex app right now, and the other half in VS Code.
Yeah,
but VS Code is only there to review the database.
Yeah.
Or to find a file that I want to point the agent to.
Now, can we jump into a little bit about the actual product that you're going to be releasing? I don't know what state that is. I think you're pre-release, right? You're still in that building phase.
The Excel one is actually already out there and being used in production. The PowerPoint one is pre-release for putting the finishing touches on that. Right.
Okay, these are headless products. So
yeah, so
how does that work?
Essentially, we've re-implemented first of all, the Excel and PowerPoint are essentially clients that know how to read and produce Excel files and PowerPoint files, which are actually perhaps somewhat surprising, an open standard. Like the Excel file format, the PowerPoint file format is an open standard. What we built is another client to handle those files that is designed to run in the main interface is a CLI that runs in the terminal and that the agent controls through code. But unlike Excel and PowerPoint, it's designed to run in a server, run in an agent sandbox, run many copies in parallel, actually make it sandbox so that if something is funky with that file, it doesn't blow up your entire computer. And that's kind of the main idea. And then on top of that, we've actually added some stuff that doesn't exist in Excel or PowerPoint, with, for instance, the concept of a linter. Like there are linters for basically every programming language out there, and coding agents find them useful when they're working on them. So we've built a linter for Excel files that catches semantic errors that are not literally errors in the file, but things that are probably incorrect and probably not what the agent meant to do. And we have those verifiers. So the one is the linter, the other one is the calculation engine, the other one is the rendering engine, which takes any range in the file and renders it to an image so that a multimodal model can see exactly the layout that it's producing with all the formatting and white space and so on. And then everything is orchestrated through a single scripting interface so that the agent can basically combine all the operations it wants into a single tool call and control the file through code.
And what kind of put you onto this particular use case and problem to solve? Why do you feel like this needs to be addressed? And give me an actual real world example of what you couldn't do and what you can now do and how it might be used. Obviously for Excel, it sounds like a fintech domain or sector.
Yeah, I think this is still very nascent, so we're still figuring out a lot of the use cases, but it's really in sectors where either the work output is one of these files or the input is one of these files, and you want to automate some of this work in a way where maybe you have some batch process and every night you receive a bunch of Excel files from a bunch of your suppliers, and then you need to convert all that information into some records in a database, or maybe you have the opposite, where you have a bunch of records in your database and you need to then send some of that information to some of your vendors, then only accept it as an Excel file in a specific format. So those would be like simple examples of simple things that could be done with this. But then it goes all the way to, if you think of like a workflow in an investment bank or something where they produce a bunch of financial models for various purposes, then having those be able to be produced by an agent working off of all the context that was provided to it. And context is key, right? If you were to ask an agent to produce, I don't know, a valuation for company X, and you don't give it all the information you've already collected on that company, then you're just going to get something very generic and not great. But if you have actually all collected all that information, then producing that model can be a task that an agent does really well by itself, as long as it has the ability to verify its work.
And why, before you started solving this problem at Witan, like I would have thought that you could have given an agent a CSV or an Excel file and asked it to do something, but would the accuracy have not quite been there for long-running tasks? What was it getting wrong? And why did this need to be solved in your specific approach?
Yeah, a good question. So basically, there is a great alternative, which is what everyone else is doing, which is to build an add-in for Microsoft Excel or Microsoft PowerPoint, which is literally like a sidebar that shows up inside Excel or inside PowerPoint. And that's, for instance, how Claude for Excel works or Claude for PowerPoint. And that is the reason that those companies build that is because outside of Excel or PowerPoint, all you have is basically really crappy versions of open source libraries that implement 30% of the formulas that exist in Excel or that don't produce valid Excel files. Whereas in order to have an agent that works, you need a full fidelity of actual Excel. So you basically have two options. You either do that plugin, add-in sidebar inside Excel and PowerPoint, and you're able to produce these models and these outputs. The problem with that is you need the human to be clicking to be there because it's literally running on the user's computer, right? And while it's doing that, it can go and do something else. It can't close the laptop. It can't do that overnight. It can't do that 1,000 times. And so that's the idea with having these headless versions, is giving that same power that makes those agents super, super good, but available to run in any server.
Because I could see that if you're a financial company, you're going to be emailed at midnight your trades for the previous day by your broker, and they need to be reconciled so that everything matches before your day begins, right? So that would be the typical use case. And you're saying that previously there just wasn't the way to take those XLS files or something that wasn't in a very basic file type, like I'm assuming CSV is the one that people will reach to, right? And you would just not be confident on the output. You could have the agent go and look inside the directory, grab the file, but because it didn't have full kind of training on how to handle that file, it might make mistakes. And if you've got 1,000 trades, is that effectively what you're thinking about?
Yeah, it's basically death by 1,000 cuts. So it either can't open the file because it uses some Excel feature that open source library doesn't support, or when it edits the file, it produces an invalid file that then can be opened in actual Excel. Or if it changes some formulas, it then makes a mistake. Coding agents also make mistakes when they write code, right? Or it tries to produce some layout and then can check what it produced, can check like an image of what it looks like. So it just ends up not looking right, having some column cropped or some other worse mistake. So it's just, and as you said, the errors just accumulate if the agents don't have the ability to validate their work.
And so you see, because it's a really important point that like the whole thing you're working on is just to make better tooling for agents so that they can run with higher accuracy for longer autonomously, which is the difference between being a co-pilot, right? You're basically there with Excel open on your machine and you've got the sidebar. That's the co-pilot. Autonomously is you can just let it run for 12 hours, let it run in the background as your reconciliation agent, just doing all of that work. That's super useful for any finance company or doing anything to do with where you need to just live in that space. And you've done Excel and you've done PowerPoint and you're moving on to, you've probably got a long list of kind of high value.
Yeah, we're trying to figure out what are the next tools we should build. The idea is not, we're not trying to redo the Office suite or anything. We're trying to make headless tools for autonomous agents. And so Excel and PowerPoint were nice first targets. But next, anything that fits the bill of verifiers are useful, as in there's some system you can give it to validate the work as it's happening. And maybe there's some popular file format or some interface with the real world that needs to be given to the agent in order to produce work that then someone can review. Anything that fits that bill is something we'll consider doing. We're currently focused on finishing PowerPoint, and then we'll think about what the next one is.
Move on to the next. And it's all in service of this idea that everything's moving a little bit more towards autonomous, long-running workflow, I don't know, automations.
Yeah, it's all in service as making agents more useful. Because I think what I've seen is that agents are already super useful, but in order to make them be used in all the other verticals and industries that haven't even been touched by AI yet, I think there's some of these pieces are missing in terms of how to make agents interface with whatever that industry currently uses.
Yeah, as soon as you really get a sense, as soon as you step out of this very optimized lane of coding agents, everything slows down and you begin to come up against brick walls and problems. As soon as you want your agent to work in a browser, for example, it suddenly becomes really slow as it snapshots every page, and then it kind of converts it, and then it considers it, and then it takes an action. And those things outside of that, just very optimized coding a use case, it's actually, there's a huge amount of work still to be done, which I guess is, where you're getting at. That's super interesting.